All right. Jumping straight in today, I am working on hopefully creating a thing to use TileGrid, which is one of the built-in sort of main building blocks of Display.io, to basically make a way that we can easily inflate, is the verb I think of it as, inflate an image to show on the screen from a smaller sprite sheet than the actual image ends up. This page over here might be a better example of this. This idea for tile map games is very, very, very similar in nature to what I want to do for bitmaps to just use in arbitrary places. Basically, this is a technique that utilizes a smaller bitmap like this, a smaller sprite sheet, actually, I should say. So this sprite sheet, if we focus on the walls and the floor here, there's 9 tiles, essentially. This is like a 3x3 grid of tiles. But then using the TileGrid class, you can make a bigger tile grid and then specify the indexes of which tile should get used at all these different locations. So this gives you the ability to build a bigger looking, in this case, room for like a tile map game. But really this is just build a bigger version of the image using a smaller subset of the tiles, or not really a subset, I guess. It's got all the tiles it needs. We're just using a smaller sprite sheet, and then in this bigger tile grid, we're kind of determining which tiles are just duplicates. So if we kind of take this one as an example, 1, 2, 3, 4, it has duplicated these 4 tiles along the top, and they are the center top one here. So in the sprite sheet, there's only 1 of this tile, but they have multiplied it out to 4 in this example up here. So this is kind of the principle that I want to explore a little bit today. The first place I want to use this is the tab layout, which I was working on stream this past Saturday. So if you're interested in kind of my first sort of place that I want to utilize this functionality, that's it. You can follow along with that. I did the whole creation of that class on stream. So if you want the history of that, you can check it out on probably the YouTube VOD. You should be able to see it there. It might still be on Twitch. I think the Twitch VOD's saved for a little while, but I do think they go away, whereas the YouTube ones tend to stay up. So that's the place to watch this. The VOD, if you're catching this anytime in the future, is YouTube should still have it, but Twitch may or may not. I think they get removed after a couple of weeks or something. And to kind of expand on where this idea comes from, at least in my mind, it comes back to these things in Android. Android has this 9-patch PNG concept. This is the first place I ran into this concept. I don't know, I'm sure it probably exists in other places. I mean, in fact, it really is the same core concept as TileGrid and this sort of room here. It's just basically been put into a custom file format that tries to compile everything it needs to know all in one image file. In this case, it's a PNG image file, or specifically, it's a .9.png image file. So it is still a standard image file, but it has the outermost row of pixels, so 1 pixel border all the way around the whole image, is reserved for basically declaring the size that is stretchable, like what part of the image is stretchable and what part is not. These are kind of some weird examples of it. I guess this is a newer one. I tend to think of it more as the dots in the middle. Maybe there's like something in here that will be an easier. Yeah, this is This is a pretty, or this one is even better, honestly. Although this is tiny, I guess, but on 9-patch. Oh wow, this is like old school Android dev docs. This is interesting. Okay. This gives you a good idea of what's going on, though. Basically, in Android, they have these 9-patch PNGs. On this outermost row of pixels, you fill in black pixels, and the different sides represent different things. So if memory serves, the top and the left, any of the pixels that you fill in with black dots on these outer top and left edges, and then you load it into the app using this 9-patch loader, it will know that these columns where these black pixels are at and these rows where these black pixels are at all the way across, this will be the area that is eligible to be duplicated in order to make a larger image, like how we were talking about here, how this duplicates some of the tiles. This idea is basically using these black pixels to say these are the columns, these are the pixels that are eligible to just be duplicated over and over in order to build up a larger copy of this panel or this image, basically. And the reason why this is helpful is because if we duplicate these middle pixels here to add more, then our corners will stay in focus. Our corners will stay sharp. You know, you might think like, well, why don't we just scale? You know, why don't we just use a small image and then scale it up? Well, if we scale it, it will get blurry. It will lose focus. Whereas what this does is it maintains the resolution of the corners. Those stay exactly how they were in the image, but then that inner portion can be built up to a larger size by duplicating these pixels. And this one also shows a preview of the output of it. So like this would be the input 9-patch in this case, and then this one is showing one that is stretched like really far tall. So a bunch more rows, like right here, have been added in order to make this bigger tall one. This one is, you know, kind of the opposite. A bunch of the columns have been added here based on this pixel to build this out to be a wider one. And then the third one down here, you can tell, is basically both. It's had pixels added both in rows and in columns to build up a much larger rectangle, but it's still keeping in focus the corners. So the corners still look good. In this case, they're kind of rounded off a bit. And so I think, I don't know about going all the way to creating the file format and using the pixels on the edges. Maybe one of these days we'll get to there. But I think I want to start with just like making a function that takes the input sprite sheet and maybe takes arguments for the size of the tiles, I think. Basically, the size of the corners is really what we need. And then it also allows you to give it like an arbitrary new size, and then it will just return back to you a tile grid of the new size, filled in with all of those duplicated tiles. In the case of Android, they also have black pixels on the right and the bottom, which indicates something else. I think, if I recall correctly, it's like the area with pixels on the right and bottom is the area where content is allowed to exist. So like if you're going to put text inside of this thing or something, this is kind of telling it the padding outside the text. So in this case, the text would kind of be allowed to exist in this sort of box that's made up by the intersection of these pixels and these pixels here. And so if it's not big enough for the text that's in it, then of course it will grow using the duplicate pixels here until it's big enough that the text does not go outside of the box that these right and bottom pixels signify. And this one, they have some highlighting. It shows highlighting on the rows and columns for the duplicated pixels. But you can imagine, like, if we had highlighted the rows and columns for this right and bottom edge, we'd have this nice big rectangle in the middle here where the content is allowed to exist. I don't think I want to necessarily get all the way into that part of it. But the core idea of this, the duplicating rows and columns pixels, that I think we could definitely get good use out of in CircuitPython. And specifically, my idea is to use it for the tabs on the tab layout. I talked about wanting to have like rounded edge tabs, and I also talked about maybe wanting to have one where there were no edges, but just like underlines. Basically, I got to this by searching Google Images search, and I took a look at some of the different tabs that exist, and some of them are sort of this style where there's no like, folder tab, there's no like visual thing up here, but instead there's just an underline that appears on the tab that's currently focused. So like this is one type of tab that's often seen in newer user interfaces. This is another type of tab here, though. This is like kind of the original one I was thinking, where you have actual, rounded corner folder tabs up here, and then, like maybe some of them are gray and the focused one is white, or whatever you want there for a visual indicator to show which one is currently focused. But I want to be able to hit both of those use cases as well as many other use cases. I want people to be able to customize the tabs in their tab layout. So, if you want turquoise and gray instead of white and gray, if you want blue tabs, if you want, underscores and no top curved corner things, if you want, over lines instead of underscores. Ideally, I want to be able to build this thing generic enough that all of those will be possible to do. And I think this idea of these 9-patch images will fulfill that for us, because you could always create the exact custom kind of tab you want as this little sprite sheet, and then actual tab layout won't have to treat it any differently based on all of that stuff. It'll, the only thing it will know is like you gave it a sprite sheet and you gave it the details it needs to know which parts are duplicatable, and then it can create an arbitrarily sized rectangle to fill in on the screen. It doesn't need to really care about colors or corners or underline or overline or any of that stuff. It'll just take the sprite sheet, and then you just include that stuff in your sprite sheet. And eventually, I think we'll provide support for 2. So there'll be the like standard tab sprite sheet, and then there'll also be the focused tab sprite sheet. So that way, you have the ability to make the one that is currently focused look different. It can be a different color, or it can be the underlines, or whatever you want to do visually to separate those, you'll be able to, since you'll be able to put it inside of this sprite sheet. Okay, so that's the plan. I think to start with, honestly, the first thing I'm going to do is just make a test one of these images to work from. And I don't know exactly how big. Let's say, to start with, let's say we're going to do maybe 16 by 16 sprites, like 16 by 16 tiles, and then let's call it a 3 by 3 sprite sheet. So 16 times 3, what is that? 30, 48, is that right? Yeah. So let's make one of these at 48 by 48. Let's put transparency. We're going to have to change it to solid color because we're going to be in bitmap land, which doesn't have transparency, so we'll get there eventually. Let's start with, I don't want to do black and white. Let's start with a blue just so we have something we'll be able to see later on the screen. Let's maybe make it on the lighter side so that it's easy to see against black. Default color for the screen is black, so. And let's make a really basic one, I think. Is there a curves drawing thing, or angle? There's a rectangle. Can we make a rounded? I think we can round the edges, right? Can we do something like this? Let's see. Shrink by, let's see, 16 is our tile. So let's say maybe shrink it by 4. And then can we do rounded corners? Round rectangle? Here we go. Okay. Radius. Radius has a percent. Interesting. I don't know. I don't know. I guess we just have to do this and see how it comes out. Okay, yeah, that's pretty much what I'm after. So let's do something like fill this in and then shrink again. Another 4? Yeah, let's shrink another 4. And then let's fill it with white. And then that'll be good enough as a tester. Okay. So our goal will be able to expand this to be bigger, of course. This file is only 48 by 48. What we'll try to do is use the magic inside of TileGrid to make it so that we'll be able to instantiate this thing and make it like 100 by 100, but the corners will still look good. They won't get stretched out and weird looking. That's kind of our goal. So we need to convert it. Let's go mode indexed. Yep. Okay, we got a little rougher on the edges because it took out some of our colors. We must have had more than, well, those were like half opaque, I guess. Yeah, those were like half opaque, which we can't do. They're half transparent, half opaque. Maybe not exactly half, but they were partially transparent, so they got removed. I am curious, how many colors do we actually have here? Oh, not many at all. Okay, yeah, like 10. I do think we want to be able to represent transparent. So what I'm gonna do is actually add a layer. What should our transparent color? Should we go all the way pink? Go all the way green. I like to use generally either pink or green. I've seen pink used a lot in video game assets. And then green I use sometimes because it's basically the idea of a green screen. It's pretty much the exact same concept. Okay, so what we need to do actually is do this before we convert, actually. Let's go back here, then do this, and then convert back. There's no image mode, indexed. And then I'm going to put the pink as the first index. Okay, it already is. Okay, so index 0 is pink, and then in our CircuitPython code, we'll make that index 0 transparent. Okay, so let's save this. I will. Where should I guess I should make a new repo. Why don't we make a folder for this? Let's see. CircuitPython. I don't know the right name for this, honestly. So let's call it for now like CircuitPython bitmap inflator. I don't know. Inflator. Might try to come up with a better name eventually. I mean, if we follow the rest of the 9-patch format from Android, we could call it like 9-patch bitmap. They use PNG files in Android, but we could do the same with bitmaps. Just if we get the whole thing though, like the black pixels on the edge and everything, then I think it makes sense to reuse that name. To start with, I'm not going to worry about the black pixels on the edge yet. I'm going to try to just do it with passing in numbers. So the numbers will tell it where the corners are at, basically. Later. So we're going to open this. And pretty much, let's go directory images, or let's call it BMPs, actually. That's shorter, and they're going to be bitmaps anyway. Python file, so let's call this bitmap inflator for now. Again, might come up with a different name. I think to start with, I'm actually just going to make it a function. Maybe eventually we'll turn this into a class, but I'm going to make it a function and just call it inflate bitmap. This is going to... I'm just kind of off the cuff here doing this how I think it should be. So I think you pass it the path to the image, BMP path, and then what else do we need to pass it? I think, so in Android you can declare multiple pixels as the stretch zone. I almost want to start with, I think I want to start with not even worrying about that, maybe just having it be declaring a single pixel for the stretch zone, and that one column of pixels is what will get duplicated to make it wider, and a single row of pixels, and that row will get duplicated to make it taller. Yeah. Eventually we could maybe work in the idea of multiple pixels. I hesitate to start out with it though, because then it becomes a little arbitrary. Like, let's say that the duplication zone is, 3 pixels wide, but let's say based on the size that we're building a new one of, maybe it's not divisible by 3 exactly. So then we have to decide like which of the 3 get duplicated, or how we rectify the fact that it's not divisible by 3. In the majority of cases, I think a single pixel of duplication zone will cover it. It's really kind of not very common that you need multiple. So let's call this, let's put it in our new spot. Oh, nice, it's at the top here. That's handy. Test BMP0. Very descriptively names. I'm pretty sure I put an O instead of a 0 on that. Yeah, totally did. Let me fix that. Okay. So we take the path, and then I think we take the, let's see, the X, duplicate zone, duplicate pixel, X duplicate pixel, X duplicate pixel. I don't know, I'm sure. Duplication pixel? Duplicate pixel? It's not really a duplicate pixel, it's a pixel that we're saying is okay to duplicate. I don't know, maybe we'll come up with a better name as we get into this. I mean, I think once I get some of the code written as well, some of this stuff might start to jump out at me better. So the path to the image, the zone where we can expand in one direction, the zone where we can expand in the other direction, and then the size, target size, which I guess we could just have that be a tuple. So we'll get X and Y out of there for the target size. Do we need anything else for right now? I don't think so. So first thing to do is load this image using image loader. Whoa. Which I don't know the code for off the top of my head. If root image load. Oops. Google Images though. We want search all here. Which GitHub would be GitHub. Oh, no, I want examples. All right. This will be the BMP path. And this creates a bitmap and a palette. And so if we wanted to show this on the screen, our next step is to make a tile grid. And we do ultimately want to show it onto the screen, so we are going to make a tile grid, but we're going to make it bigger. Although, actually, maybe we should just get this working at real size first. So yeah, let's actually do it this way. So let's just make our tile grid like normal. Pass in the palette and the bitmap. And then really at this point, I think return tile grid. Eventually we're going to have code in here. that does the duplicating. But to start with, let's just make sure we have the beginning of this working. So right now, this should allow me to pass a bitmap path, should return back to me a tile grid that I can then add to a group to show on the display. So let me make a bitmap inflator simple test. Okay. We'll basically just do the bare minimum to show our image. So what is that? We need display IO because we need to make a group, main group. We need to go maybe display equals. In my case, I'm using built-in. Import board. So then let's say inflated TileGrid is equal to inflator.inflate path import bitmap inflator. So the path is BMP's test, this one. Oh, you know what though? I should have maybe made it I should have made it an odd number. Yeah, I think what I'm going to do is, let's see. We have background called, we have the foreground called background and the background called layer. Let's go Control A, Control C, grab all of this. Let's make a new one at 47. We can go down a pixel. I mean, honestly, we could probably go even smaller. We could really cut this to the point where we have like basically 1 pixel after the curve. So the final pixel that is colored anything for the curve is like right in here. This one. We could basically have 1 blank pixel in here, and then we could just start the next curve right away. And that would actually allow us to minimize this sprite sheet even farther. I'm not going to mess with doing that right now, but that would be like the most efficient, I think. So we could go, let's copy this. Let's make a new one, 47. This way it's odd. This way we have an exact center. If it's sized even, then oh darn it! If it's sized as an even number of pixels, then we don't have a center. I mean, we have a center, but it's on a halfway point between 2 pixels, or I guess you could consider the center to be 2 pixels large. Let's see. Okay, so now this is 47, but we have a little bit of room, so I can paste this and we'll still be. Oh no, you know what? That's not centered. Okay, hold on. Let's X this. Let's go here. Let's do this differently. Let's go select by color. Select this. Control I to select the actual part that's real. Copy this. This will center, I think. Is it? Still does not. It doesn't look centered to me. And in fact, it looks off the other way, honestly. It looks like we're closer to the top and left than we are to the right and bottom. Is that actually true? This, oh, hold on. Yeah. Not very proficient at image editing. I know just enough to like get stuff done, but. So this is 21. No, this is. Oh, wow, we're zoomed way in, huh? That's 3 by 3. Really? Huh. Yeah, I guess so, because we had 4 for that. Okay, so we have 3 pixels there. Oh, yeah, we have 4 pixels here. So because we made this with even, we're actually still off by 1. So do we want to just remake it, or do we want to try to salvage it? Let me make an attempt to salvage it. I think what we could do is just select this, cut it, paste it as a new layer, scoot it over by 1, and now we're 1 pixel narrower. So we just do the same thing. Oh, well, we merge it down. And we just do the same thing. This orientation. Cut that. Paste it. New layer. Scooch it up by 1. Merge it down. So now this should be odd number of pixels sized. Yeah, that's looking better. Now we have, should be 3 pixels all the way around, or 4 pixels all the way around, because we got smaller, which means we have more margin. So we have 4 pixels height here. We have 4 pixels width here. 4 pixels width. 4 pixels height. Perfect. Okay. So we're even all the way around, and our total image is 47 by 47, which means the 24th pixel is exactly in the middle. So let's put our background back and then export this one. We don't need this layer though. This one's in here. Oops. Unselect, paste, image mode, indexed. Make sure pink is at 0. Yep. Okay, export it. Just copy over this one. All right. So the 24th pixel is our duplicate pixel. So 24x and 24y in this case. And then what else? Target size. Okay, so this is a tuple, and for now, let's just say 100 by 100. Of course, to start with, this isn't going to do anything because we didn't implement any code that uses it, but eventually we'll add that stuff. So now we should have our tile grid. We can add it to main group. And then show it. Display.show main group while true. Yes. I think we have to do this, or else it will only display for a split second and it will go right back away. So this should be enough, I think, to show the image. Let's close this stuff. Let's go over to device tester. This is not have a screen, so let's plug in one with a screen. It's the Titano right here. Have the regular PyPortal as well. This is what we were working on yesterday. Yesterday? No, this would have been Saturday, actually. So let's copy that over so we can keep it. I'll call this code tab layout test. And then inside of code, we'll just simple test. Oh my. I just... No. Luckily, that was actually... I replaced everything in there. Okay. I was looking at a secrets.py earlier, and I had that open, and it was on the screen for a split second just now, but it was all fake stuff. I was using that file to fill in fake stuff to go post it somewhere online, as an example. Luckily, that didn't have real stuff in it. So now let's just paste this from our simple test. So this one's like baseline sanity check. Just make sure we got our tile grid getting created how we think we do, and also make sure that our loading is working how we expect. So I'll put this in lib, and then I'll make the BMPs folder here as well. Okay, we already have TO. I'm gonna reset and change the rotation. Why? Oh, we never saved code. Let's see. It's like, why is that still running? Okay. Unsupported image format. And it was, is it not? Hmm. Did I save it as a BMP? I must not have, otherwise that, because that auto-filled. This is actually what we want. Which then means that we'll need to bring that over. Might as well just delete this one. Here as well, especially where the space will be filled. All right, and I'm going to reset it to get rotation. It is working though. So let's do that. We'll put the rotation back, and then I see it's kind of washed out. You can't really tell what color it is. Also, or it must be upside down, I guess. Looks like just white. Let's see if the light maybe in that little a bit. Not much really. Not nice. All right, hopefully that wasn't too loud. All right, well that's good enough for now. Still looking pretty washed out, but you can at least tell it's different colors now. So this is working so far. So now we do the fun part inside of here. Instead of just creating a tile grid like this, we are gonna figure out how to make one a different size. Castle tile grid. So okay. So I think So originally I did start with 16 by 16 tiles, but I think what I'm actually going to do is call the tile size 1 width by the entire height. So our tiles are going to be 1 pixel wide, and in our case for this particular image they'll be 47 pixels tall. So every vertical stripe basically will be a tile in our tile grid. And then the height and width, maybe we should work on just height or width first. Because we would not actually be able to, if our tiles are only like this, we can only grow horizontally. And ultimately I really want actually the ability to grow both ways. So we could use 1 by 1 tiles. Every pixel is a tile, but then we'd have to do things like mass copying the corners. What other options do we have here? So we can't really use 16 by 16 because we ended up changing our total size. 47, so we don't actually have a full 3 tiles. How do we want to do this? So I guess we could go back to the 48 one, and instead of you declaring a pixel, you declare a tile index. Let's try that path. Yeah. I'm actually gonna go ahead already and make this test bitmap 1. This way we have both of these, and if I end up switching back, we won't have to redo it. Test bitmap 1. So this will be not in pixels. Instead, this is actually just going to be TileIndex 1. TileIndex 1. But we're not going to be able to hit 100 exactly. Because if we're using 16 by 16, it's not going to divide into 100. We would have to use either, what would we have to use? Six. 96. So either if we wanted to stay under 100, we could make it 96 by 96, but basically we'd be stuck to multiples of 16. Actually, I don't like either. All right, let's focus on stretching one direction at a time. And maybe we'll come up with a way to do one and then do the other one, maybe? Because I have a pretty clear idea if we're only stretching one direction. It's kind of the way I was thinking at first was how I started to talk about like this. So our tile will be this. It will be one pixel wide and the entire height tall. So we will declare this by pixels. And then, so we still pass the image. We need to give it the width and height in tiles. So the height is going to be 1 in this example. And again, eventually I'm going to have to figure out how to deal with the other orientation, but let's see if we can do one at a time first at least. Width. So the width is going to be the target size X, which is 0. So in the case of this, our target size is 100, so our width will be 100. 100 tiles wide, 1 tile tall, which makes sense because our width is exactly 1 pixel and we're asking to get up to 100 pixels. In this case, we actually have the outer edge, which I'm going to end up making transparent. So it's going to be smaller than 100 on the screen anyway. The blue part will be. And the pink part eventually will be transparent, but this is kind of the beauty of this design is you can like include the extra space if you want margins inside of here. You could also do stuff like rounded corners on the top and square corners on the bottom, which is another one of the things I knew I wanted to try to support with this tab layout. All right, so I think that makes sense. This would end up being 100. Our height is 1, and then we need tile height and tile width. So tile width is 1 pixel. Tile height is the height of the image. Height. I think we should be able to do that. I don't know from that list, but I'm pretty sure bitmap will have a height and a width, hopefully. And then, I mean, what is that going to look like? I have no idea. Oh, okay, so, yeah, you know, again, it's washed out, but basically what we got is a pink rectangle. So the blue is nowhere to be seen. And so basically now we just need to, I guess that's probably the right width. 100. It looks like about double the width that was there before, and since it's 47, it's just a little bit over double. So it does look like the right width. So we just need to set the actual tiles correctly. So let's look back here. I don't actually use this stuff a lot. I got really into learning this for the tile map games, and I've played with that a couple of times, but I certainly would not say that I have like an immense amount of experience with this. So basically we need to go and set for each of our tiles which source pixel, which source tile. So in our case, for the very first 23, it's going to be the first for I in range X duplicate pixel. So this we're passing in 24. this loops 0 to 23. So I'm off by 1. Do we want to go to 20? I want to go to index 23. That's the 24th tile. Yeah, we go -1. I'll go back later and I'll do this with one that doesn't have the pink, and then we'll measure pixels, make sure we're not off by 1. So basically from 0 to 22, we want to go TileGrid I. And is it a tuple inside of here, or is it? Yeah, okay. And then this is going to be 0 always, right? Because we only have one tile height. Equals so this is actually just 0 to 22. We could actually just put I. But then the other end will be a little bit more challenging. And I guess we could do both inside of here, right? So we could say TileGrid size 0. Let's go width minus I. So the first one it would get would be 100 minus 0. So I think we actually want to -1 more. -1 minus I. So 100 minus 1, index 99, which is the last column of pixels in our tile grid. So that's the far right edge. And then we'll count back in 1 by 1 pixels because we'll be subtracting 1 more. So the second time through, we'll get 99 minus 1, which gets us to 98. Third time through, 99 minus 2, which gets us to 97, and so on. And then still 0. And then this gets trickier, though. What are those? So those are going to be those, I guess they're, the first one would be image.width -1. And then if we just minus I, it's going to do that for us. Oops. Oh, didn't crash. Ah, yeah. Okay. Perfect. So the middle is messed up, obviously. But you can see we got the right edge and the left edge there. So that part's actually looking pretty good so far. And then for the middle, we basically want to do the middle. We basically want to just fill it in. Is there like a TileGrid.fill or something? Is there a way I can fill every tile at once? So I guess we could just fill the entire thing. Oh, well, we're not there yet. No, okay. Hmm. Oh, default tile. Okay. Maybe one of these days I'll try to make a fill. Might be nice to be able to specify this after the fact. In this case, this will actually work though. Default tile. Uh, it will be the X duplicate pixel, but -1 or maybe -1. Yeah, it should be -1, I think, because it's the 24th pixel, but that's one based counting. So in 0 based counting, it's got index of 23. So that should actually fill everything with that inner stripe to start with. Yeah, that's what we're after right there. Okay. All right. That was pretty straightforward. So now let's think about how would we want to be able to stretch vertically also. Hmm. Yeah, we might have to go down to 1 pixel tiles. 1 by 1, I mean. We have 1 pixel width right now. I was thinking maybe there would be a way to do the width and then the height afterwards, but I don't think so because this is not. So this is not a bitmap anymore. This is a tile grid. So I don't think we have a way to access a full horizontal row. But this is pretty good. This is exactly what I was aiming for. So we did 100 here. We could just as easily do a bigger one. If this was 200, it could be twice as big. And the corners stay looking good. The corners don't get like stretched out or anything. Yeah, I think, I guess we must end up needing 1 by 1. I suppose when we get to the point of allowing more than a single pixel of stretch zone, then the width of the stretch zone could be the tile size, and then maybe we could start not having to do 1 by 1s. And then basically, I guess we'll just make the rule that it'll go to as big as it can be and still fit within the bounds that you pass it. So if you pass it 100 by 100 like we have, and you had tiles that were 16 by 16, then actually 96 would be the final size you end up at. And then we would just not worry about the fractions. We would basically truncate off the fractions. It is weird though, at 47 we can't Can't really do it with tiles at 47 because we don't have an equal divisor. We almost want to pick a size that's divisible by 3, but also odd. So divisible by 3, but not divisible by 2. If we picked a size, so like 45, for instance, at 45, we could have tiles that are 15 by 15. But we are still odd, which means we do still have a single pixel in the center. Although at that point, do we care about having a single pixel in the center? Not sure we do, I guess, if we're doing tiles. All right, well, let's try the 1 by 1 pixel case first. And then I'll swing back around maybe and work on the tile case. Because really what it depends on is the size of the detail. Like the detail in our case, the part that's not duplicated are the corners. The center is going to get duplicated in our case, but the corners have to be unique. And so really what you should, I assume what would be most efficient is aim for the biggest size tile that you can while still leaving yourself a single tile that's duplicatable. Okay, so let's give this a try. Let's say these are in pixels. Eventually it might make sense to declare these in tiles instead. What I'm going to do is like comment these ones so I can keep them, but then start some new ones will become the real ones. So this time target height, target width, and then tile height and width, these are both 1. Well, tile, this gets harder. Let's just leave it out for now, default tile. Okay. How's the logic going to work on this one? So to start with, I guess this is going to be looking messed up, probably. Should know. But okay, yeah, so we just get pink. 200, and we're 200 by 100 here. That'll be a good test size when we get to it. So I think I almost want like a helper function or something that can copy a region of Be a region of pixels, basically. Region. Is there like a? Do we have like collections or anything? Is it along this? Generic name tuple. That's not really. Is there? Is there a thing that will copy part of a two-dimensional array into another two-dimensional array? Copy. Oh no, I don't really want to make a copy of it. Really, so we'll have a two-dimensional array, which is our sprite sheet, which is 47 by 47. I want to be able to say take a 23 by 23 sized box, grab all the values from our starting sprite sheet in that 23 by 23 box, and then put them into our tile grid. It's not really that we want to create a copy of it. It's that we want to like copy the values out of it. NumPy to get it as a column. That's not really what I want either. All right, well, let's say, I guess let's make a function. There may be this may exist somewhere, but def copy to dim region source two-dimensional array will be our image. All right. So, because we can do like print image 0, and that will print a color index. Yeah. And our image is 47 by 47, so that's a total of 2209. So if we wanted the center pixel, what would the center pixel be? Because it goes left to right and then down, so it would be something like 47 times 24? 23. 37 times 23 plus 23. Roughly that would be the center pixel. I may be off by 1 or something in different ways, so that would be like 7 times half of 47. Maybe it's supposed to be 22. I don't know. I could be off by 1. Really, I'm just making sure that this actually does what I want, which is access the pixels in there. And then plus another 23. Let's get us. This part gets us half of the way down. The 23 gets us to the middle of the current row. So this should print just another color index, and it should be the color index of white, wherever white's at in the map, which does look right. 10 looks to be white to me. There's a couple of them that could pass for white, but I assume 10 is the bright white. Okay. So we can copy out of there. So our source. Let me look in bitmap tools. There is something that does this for bitmaps. Maybe it could be used with TileGrids too. ArrayBlit inserts pixels from data into the rectangle of width height pixels with the upper left corner at XY. Values from data are taken modulo the number of color values available in the destination bitmap. That part means if X1, Y1 are not specified, they're taken at 0. This might be doable. It's looking for a bitmap, but maybe we could give it a tile grid here and it would still work. Let's give this a try, actually, because if this does work, then we don't need to make a function for it. So what if we try saying, like, if we try something like this, bitmap tools dot, what was it called? ArrayBlit? Or bitmap blit? What was it called? ArrayBlit. ArrayBlit. So the bitmap is where the data is going to go into. So in our case, that's the tile grid. The data, in our case, is actually coming from the bitmap. So then let's say the top left corner of the area to blit. So let's say oh, no, this doesn't do what I want. This is what I want. So X1, Y1, the left corner of the area to blit into, the top corner of the area to blit into, X2, the right, the area to blit into, bottom corner, the area to blit into. But it doesn't take a region blit from. Insert pixels from data into the rectangle of width height pixels. this going to do? It's like part of the way there. It would need a couple of more arguments, I think, though. Because I want to be able to tell it, basically take a region from the source image and blit it into a given region in the target image. This is gonna pick the whole data and blit it into the target image at the specified, or I don't really understand how this works actually. Why do we have 2 points? I wish I could visualize. A very visual geometry XY type person. I guess let's just try it. So 0, 0. 23, 23. 3 is index 23 is the 24th pixel. Skip index. Bitmap palette index. I don't think we need that one. That must be a type bitmap. So we can't copy it into a tile grid. Okay. Source dim, dest, to dim. Basically what I want is x1, well, why don't we, let's do tuples. So top left point, bottom right point. This will define the region that we're gonna copy, and then dest point will be the top left of the place that we're gonna copy it to. So now we're gonna go do for loops. For x in range top left point 0, so the x1 basically. Maybe it would still make sense to write this in terms of x1. So now this range goes from x1 to x2, and it counts by 1, which is default. This goes from y1 to y2. Looping over rows, and then looping over columns. And for each one of these, basically, Hmm. This is Y pixel. Index. X index. X pixel. Okay. So this is looping through. Now we're going to go destination. X pixel, Y pixel. Equals source. No, this is wrong. These are wrong. These actually go here. Source, X pixel, Y pixel. Read it from the source at this location. And then the place it goes is actually dest X, dest Y. Place it goes is actually dest X plus X index, dest Y plus Y index. Okay. Again, I'm a visual person, but I think what this will do is let us basically declare a top left corner and a bottom right corner, and then copy all of the pixels, which in this case, really the thing it's copying are the ints, the color indexes that are stored inside the bitmap. It's going to copy all of those to a specified starting point in the destination. The destination starting point will be dest point, and it will basically go out and down from there. So dest point will become the top left corner of the region that we're pasting, basically. Yeah, that does make sense to me. So then let's say copy this. Source is image. Dest is TileGrid. And I'm going to just do something like this to test it out. And then, oh, wait, we did tuples. Whoops, tuple. Let's do 0, 0. So we're going to take a 24 by 24 region, copy it into our tile grid starting at 0, 0. So we should see the upper left corner of our image in our tile grid, if this works how I'm imagining. We do not. Okay, let's do some of this. Def print. It's so big though. 7, I guess it's not that big. It's not that big. It's kind of big though. Print 2dim. I don't know. Data object, I don't know. I don't have a good name. So I don't know, how do we get the length either of each rows and columns? Well, we should have height and width. I'm just gonna call this print bitmap, but it's actually, I think it should work the same for tile grids. So loop over the rows, and then for each row, I want to print space.join Can you access it with 2 square brackets? Can I do that instead of 0, 0? No. Okay, so I need to get the whole row. Hmm. Okay. So each row we're going to make a list. We're going to loop through 0 to the width. We're going to look up the pixel at cur x and cur row. Send it to this. Print it with spaces separating. This would be even better if we had only 9 colors, because 10 is gonna throw off the spacing. Let's see what it looks like. So just print all the rows. Yeah, I think this does what I want. So let's just try printing image, print bitmap image. And expects a list of string or bytes. Do this wrong? And expects a list. Okay, this is what I was. Part of what I was afraid of is the 10s cause this to go wider, which then makes it wrap. It does look like this has what we want, though. Editor. Alright, well, doesn't look like we can. I guess I could write it to a file or something. I don't know. Just use a smaller image, I suppose, too, for testing. But nice if we had the ability to do that. What are we ending up with after we do that? Aren't we setting these pixels? Zeros. We do have, no, we have some ones. That's it. I mean, it's impossible to look at, obviously. But I did kind of expect to not see anything except zeros. And the fact that we do have things that are not zeros. Like it would be a good thing and would cause us to not still have a blank pink rectangle. Why do we still have a pink rectangle? Yeah, it does. So maybe we can override this to make it print nicer. So now I want to print only the corner, only the 23 by 23 in the corner. So it prints less stuff. I can actually use these. Yeah. Okay. That looks right. That looks like what I would expect. So why is it not drawing here? We should have the first 23 pixels should be the top left of our rounded box. And we print it after we copy. And it has the right stuff in it when we print it. But then when we look at it on the display, we don't see those pixels. Move it? Is this a refreshing problem? No. That moved down. It's bizarre. Print inflated tile grid. Three 23. Zero. And 10 is white. We don't see any white. We still have all pink. So how can there be 10 in the tile grid when we print it, but no white pixels on the display? This is really bizarre. Feels like we copied it successfully, but and then even when we go and access it and print it, have the right values, but it's not display. As if they're all zeros on the display. Okay, so this will turn the left half of the first 4 rows to white. That's what it should do, but we again still have only pink. And I don't know. Hmm. Yeah, I'm a little bit lost. I don't really know. This is so weird because when we did this one, it worked fine. We got the wider one and it copied over. So, I mean, right now, the place my mind is going is like maybe this image is not staying in memory. Maybe after we return here, this image is gone from memory, and therefore, when it gets drawn on the screen, it just doesn't know what those pixels were, even though it has indexes. It doesn't know what color they were, or the palette, I guess. Maybe the palette, if that got deleted, garbage collected after we returned, and I guess maybe it couldn't show the right ones, but I think if that were the case, then this one we did before, where we did the width only, shouldn't have been able to work. This is very weird. Okay, let's take this out of the mix. For Y in range, just gonna hard code some stuff here. Sanity check. 23 for X in range 23. TileGrid XY equals image XY. Should turn off the prints. We have all the same stuff here. We still have all pink. Hmm. I am baffled. I'm not really sure where I go from here. Is this... Makes it seem like I don't actually understand how tile grids work, which is pretty integral to this idea. I don't get how this one worked. So I mean, I don't get the difference. Fundamentally, we're doing the same thing. We're assigning indexes into our tile grid. It's the same thing we're doing here. And when we print it, they come out correctly. I don't know. I don't. I'm a little short on ideas, honestly. I may have to set this down and come back to it later. I'm really unsure about the difference here could be. Okay, let's not call this. So create the tile grid. And then just loop over 23 by 23, and let's just set them to 10. They're all 10s. But they're all pink. I'm setting. Am I setting the wrong values? Yeah, I'm setting the wrong values. We're not supposed to put. Okay. We're not supposed to put palette indexes in the tile grid. We're supposed to put tile indexes from the image using this counting scheme. So 10 is still pink. The reason we are setting it to 10, 10 is actually there, but 10 is all pink because we're using this as 1 by 1. And so the entire first row is pink. The entire first 4 rows are pink. So would this give us first 23 pounds? Tile value out of bounds. That feels very power of 2. Importance, like maybe there's a hard-coded maximum. We can actually use. Maybe we can't have a tile grid this small or large. It's basically we can't. Maybe we can't. Our source image width over height, or width times height, needs to be less than 256. That's what it seems like. Maybe this 1 by 1 idea is just not going to work, and I have to go to the tile idea. I was kind of liking the 1 by 1 because I wanted to be able to like have a truly arbitrary size, so you could say like 100 by 100 and it would give you exactly 100 by 100. And I guess we could, as long as we the square root of 256, 16. If our source image was only 16 by 16, then we could do this 1 by 1 tile grid. That's my guess. What is the actual error? It says tile value out of bounds. Yeah. Hmm. I mean, this seems incredibly dangerous, but what if we weigh this limitation? Seagrover, sorry, I don't know how long ago. Put this in the chat. After transformation, try removing the bitmap from the group and reappending it to see what happens. Yeah, I'm guessing that was probably a while ago then. My apologies. I can try that. I think this was probably back when I was questioning why it wasn't changing, and I think I did figure out though that it is technically changing. It's just that all the values I was putting into it were expected to be pink, unbeknownst to me, basically. This restriction might make it not possible to do it how I'm trying to. I don't know if this is like. I don't know what will happen if we take this out. Old info, you're on better track now. Okay. Yeah, sorry, I wasn't. Got in the zone there. Didn't keep an eye on the chat. Let's see. Even if this works, I don't. This is probably not the solution that we'll go with. Curious though. Oh, I didn't do the unmount thing. Those are good things. Yeah, for sure. Okay. Hasn't just like bricked itself or anything too terrible yet. It's still counting. It's gonna count pretty big. Okay. I mean, it's not pink. That's a start. I don't know. What is my actual code right now? No. I did, it ends up, oh, it wrapped. Yeah. Okay. I figured that was probably too good to be true. So it's not, there's something else, limiting the, limiting this to 255 as well. I don't know where it would be though, I guess. Subscript. I mean, I would have expected to find like another 255. In shared binding? Shared bindings do. Oh, I'm in shared bindings. Shared module, maybe? I guess probably in shared module. So my guess is it probably has a modulus inside of shared module that is further limiting us to 255. Or not. Let's try to find subscript. Subscript. Set hidden. Previous area. Update current X. Current Y. Transform. Update transform. What does transform do? Have to self look into transform. Set Y pixel shader width, height, tile width, tile height, tile. Set tile? Flip X, flip. Set flip X. I don't know what flip is either. Transpose. Top left. Fill area. So how does the subscript subscript? Somehow they're, well, inside a set tile maybe? Somehow this is still limited to 255. Set tile. Interestingly, this ends up, so this was checking the bounds between 0 and 255 and then calling set tile afterwards. And then the first thing inside set tile is also checking the bounds, but it's checking it on tiles in bitmap. It does seem like it's just setting it right here though. Ah, Python tiles. Okay, so I don't follow it all the way, but I think these modulus are having the effect of basically keeping us capped. So now we're ending up going 0, counting all the way up to 255, and then wrapping back to 0, where we should ideally keep counting up. I do think this is interesting, where in here it's checking a different range. I mean, really, I would think once we make it to shared module, we just don't check the range at all. And shared bindings already has a check on the range, so shouldn't need to check it again, unless I'm misunderstanding. I feel like these are both checking the same thing, though. This one's calling it value. It's the one that value object, one that we set it equal to. And it goes and calls set tile value as the last parameter. Set tile index is the last parameter. And then first thing in here, it checks it again for this range. Interestingly, this time we don't raise. So tiles in bitmap, it's bigger than 255. Otherwise, this would raise. I mean, here it seems like it's pretty much setting the exact tile we gave it into the location. But then afterwards is where it gets a little less clear to me. Create an area, create another area. Not partial change, tile area equals dirty area, else tile area equals temp area. I don't think has a definition yet. EX. Modulus. Within tiles. UI. Tile. I don't know, width and tiles, I mean, the modulus does seem like what's capping us based on the output, but surprised that width and tiles would be $256. If it is 250, I mean, if my theory is right, if this modulus is actually what's capping it, I would think width and tiles, I mean, our tile grid has a width of 200, not 256. I don't really get what it's doing with this TY and TX. But either way, I'm surprised the 255 is still the exact number that we are wrapping after. It makes it seem like there's somewhere else where there is a limitation at 255. I guess it could just, I mean, I don't know, is there an int that only goes up to that? Is there like a small int? Maybe it just can't go any bigger? Or, seems interesting. Private API for scrolling the tile grid? I rebuilt a camera object when I made the tile map game for scrolling. If there's a way built in to scroll, it's super helpful. I don't know. I don't know why 255 is still the magic number. I do think that's got to be what's happening. And I also don't think it's probably not very fruitful to keep going too far down this road, because at the end of the day, we don't really want to have that change. 434. At the end of the day, we don't really want this. Unless it's like, if this was a completely arbitrary limit that had no other effect on anything, then taking it out, maybe. But I assume whoever wrote this, like, there's probably more of a reason why this is the bounds than just we chose this as a bound. It could be. I mean, there has to be a bound somewhere, and I guess we could say, like, this is as big as much as memory as we want, so maybe it makes sense to use, but certainly, even when I remove it as an artificial seemingly limitation here, we still end up limited by it anyway because of something inside the modulus. So I think this is not probably the right answer. So I think I'm going to have to probably go back to the drawing board a bit, and this is an interesting portion of it that we got. I don't really know. We got a little bit of the turquoise. It's super hard to see. It's probably not going to come through on the camera. I think I'm going to have to go back to the drawing board, though, and I think I'm going to have to be able to be all right with the tiles being bigger. We're going to have to make it work more like this, where we have tiles, let's say 16 by 16, and then the user is going to tell us the tile that is repeatable, not the pixel. And so then we'll have to do all the math based on tiles instead of pixels. And so they would be telling us, you know, this index 1, if it's 0, 1, 2, they would tell us index 1 is the tile that we are allowed to repeat. Same thing over here. Index 1, so it'd be 0, 1, 2 here. Index 1 is the part that can be duplicated, which does mean we can't hit arbitrary sizes. Our sizes have to be even multiples of, well, if not, maybe not even multiples, but they have to be related to even multiples of the 16. So we wouldn't be able to hit 100 by 100, but we could hit 96 by 96. And that'll just have to be part of the limitations is your ending size has to be divisible by your tile size. Otherwise, it gets rounded down. I mean, 96 to 100 is not enough to probably care, truthfully. I'm probably not going to notice 2 pixels on each side difference. Yeah. But I think that'll be the plan, memory mapping. Yeah, it's basically, I mean, that's essentially what the tile grid is. I was just kind of trying to cheat and use it. Like this image here has a pretty good illustration of how the tile grid works. I was just trying to cheat though and use basically 1 by 1 pixels as my tile size in order to make it so that I could just arbitrarily choose any size like 100, and even though I don't, well, I could choose any size like 100 and I'm guaranteed to divide evenly into it because my tile size was 1 by 1. So it got around that limitation of needing to be an even multiple by just making the thing 1, and everything everything is an even multiple of 1. But I think we can do it the other way too. I do not think I have the energy or concentration left to do it now, though. So I am probably heading out, and I will have to come back and try and tackle it this way. I probably will need to think a little bit around, like, if there's anything else that changes. Like, maybe we shouldn't. Should we not take pixels? Maybe we should take tiles instead of pixels here too. I mean, if these duplicate zones are going to be tiles, and so that would be in TileIndex 1, TileIndex 1. Maybe these should not be pixels, and maybe this should just be, I forgot what it was, but what is it, 96 over 16? That ended up being 6. This would end up being 6, and then I guess this would be 12 probably. $92. Yeah, and we don't have enough room for another 16 in there, so then you're providing this in tiles instead of pixels, which then means you never can choose something without an even multiple. Since we're doing tiles, we're always going to be an even multiple because we're just multiplying by whatever we have here. I guess we would have to tell it the tile size. We have to tell it the tile size. Because after it image loads this, it needs to be able to set the width and height here. Tile width and height. So hard coding 16 would be fine, but ultimately we want this to work on other size things too. So I think one more parameter, tile size. Of course, it does get into the question of, like, do we only want to support square tiles, or could a user have a tile that's like 16 by 20 or something that's not square? Yeah, I would say I have a decent grasp of it, but I don't have a lot of experience with it. I learned quite a bit about it, tile grids, and the way they interact with bitmaps when I worked on the tile map game. But that's really the main project that I've done that utilizes them in this way. And I only did the one, and I kind of like fumbled my way through it, just guess and check type stuff. So I'd say I have a fairly good understanding of it, although not the limitations. Like, I had no idea there was a 255 limit. But I could use a lot more practice. That's part of, I think, what this project will be good for, is getting me extra practice with tile grids. I think this idea of expanding a smaller sprite into a bigger tile grid can be helpful for a lot of our widgets. So I'm excited to kind of hunker down and learn, get through this and get the experience with it, and then ultimately be able to use this technique for other stuff as well, like buttons, for instance. It'd be really nice to be able to make buttons like this too. Then you could have like fully customizable buttons. Right now, display button library allows you to choose colors, and there's a couple of like styles, like round corners or square corners, maybe a couple others, but this would let you totally customize it because you could just provide your sprite sheet. I think that's the plan. Glad you're going there with this. Might help me have breakthroughs. Yeah, I'm always happy to kind of fumble through this stuff, just on stream. I mean, specifically because it's good to it's good process to go through, and it's good to show folks that like not every like I don't know if I'm the person who has the most experience with TileGrid, but if not, I'm probably amongst them, having made even just the tile map game. But even me having the most experience probably is still a lot of effort and a lot of work to get through. So it's good to show people that, I think, as well. And once I do get it right, then we'll have something to point to as like, here's the process of working through it. Today's stream did not end up being that, since if you followed what I did today, you'll probably run into the same dead end that I did. But when I come back and do it with tile sizes, then we'll have a good thing we could point to for folks trying to understand how tiles work as well, tile grids. So, all right. Thanks for hanging out. I will catch you next time. I should be back on Friday for sure, but maybe another night or two this week. We'll see. I got some freed up my nights this week. For the last 3 weeks, I was teaching for 3 hours on 3 nights a week. And so by the time I got done teaching, I didn't feel like doing any more talking or streaming or anything. And then 3 nights a week is most of the week, so I kind of didn't really feel like doing much on the off nights either, truthfully. But that class is over, so I'm back to regular schedule. I may stream once again later on this week, maybe tomorrow night, Thursday night or something. Pick up where I left off here. I was wondering if ULab might have something, Microlab, if it might have something that would help us do this copying efficiency, especially this function I try to write. Let's see here. This copy to dim region. I'm wondering maybe Microlab has something like this where it can efficiently copy out of a two-dimensional array into another two-dimensional array. Although once we change this over to tiles, we won't have nearly as big of a range, so maybe just brute forcing it with for loops won't really be that bad. I mean, honestly, the way it is now still renders pretty fast. It's not rendering the right stuff, but it doesn't seem like it's taken too long. Maybe it doesn't need to be any more efficient. I would be curious, though, to go back and try to apply if there's anything in ULab that could make this easier. I think this is probably got a good chance that there's something in there that could make this easier. I just don't know what it is. Looking for matrix lists. All right, well, I'm going to head out for now. Thanks for hanging out. Yeah, I'll be back Friday for sure, and possibly one other night this week. We'll see how I'm feeling. So definitely will pick this up at some point, though. I'm excited about this. I think it'll make a good use for the tabs in the tab layout, and then once we have this ability to arbitrarily inflate bitmaps, I think we'll find other uses for it as well. So it'll be pretty cool. I'm pretty excited about it. Yep. I'll see ya.